Okay, so this is our last lesson of the chapter. So what we're going to do today, we talked about how to find the zeros. We talked about how to find, how to graph knowing the zeros, how to find the equation from the graph and all of these things. So today we're going to put it all together between this unit and the previous unit, which we did the vertex form, if you guys remember that. Okay? So what do we know about the vertex form? Where is it located? Where is the vertex located with respect to the graph? H and K, and where is that? Like if I'm looking at the graph right here, right, and I have, and this is my vertex, it's my maximum, but where is it with respect to all the other points? In the center, it's in the middle, right? It's where the axis of symmetry passes through it, because that's where my center of my graph is, okay? So it's symmetrical, both sides, right, through the axis of symmetry. Good. So basically we talked about if I know my zeros, right, so if I have a graph, and you know your zeros, right, can you find your vertex? How?
By the difference between the 2 points. So, like I say, if it's from 1 to 4, the meter is maybe 1.5 or 1 point.
So you want to use 1 and 5. So what's the middle between 1 and 5? Yeah?
No, 2. Between 1 and 5 is 2.
No.
It's 3.
Why?
Why?
One.
You are, this point is on 1, 2, 3, 4, and 5. So
Yeah.
it's 4 points. A difference between.
So it's 2, okay, you're saying something, he's saying something, and you're both right in that situation. He's saying it's going to be at the value 3, right? But you're saying it's 2 away from 1, right?
Yeah.
You both are saying the same thing, but you're saying, so if it's at 1 and 5, right? You're saying it's 2 away from 1, he's saying it's going to be at 3. Okay, good. All right, so that's good. The vertex is going to be at 3, but that 3 is what? What do we call this?
Axis symmetry.
Axis symmetry, yes, it's not centered for me. Okay, so to find the axis of symmetry, you have to find the middle point between your 2 zeros, yes? Right? Okay, good. Now, how do I find where does my maximum or optimal point, because it could be a minimum, where would my optimal point falls?
On the vortex.
Yes, but how would I find that? So if I know my axis of symmetry, I know that my axis of symmetry is 3, right? How can I find where or what is the value of my optimal?
Like doing the contrary of the partner's step pattern.
Okay.
Like going, that's good.
I know exactly what you mean. So doing the step pattern, but then it could take me forever to find them. Okay? So this is what we're gonna learn today. All right? So first of all, if it's in factored form, we know that we can find the zeros. Right? Good. So to find the vertex, if it's in factored form, the number one thing that you have to do is you need to find the zeros. Okay? Remember, the goal is we're finding the vertex. After I find the zeros, what do I do?
Find the difference. Find the axis of symmetry.
Find the axis of symmetry by adding the 2 zeros and dividing them by 2. This is how I find the middle. Okay? So I add the 2 zeros, which are called RMS in our scenario, and divide by 2. Good. Now I know my axis of symmetry and I'm looking for my optimal value. To find the optimal value, you need to plug in the axis of symmetry in your equation for x and solve for y. Remember that the vertex falls on the axis of symmetry. So the vertex, the optimal value here, has a corresponding x value, which is the axis of symmetry. So if I plug in that axis of symmetry into my equation, so if I plug in, if let's say that was 3, if I plug in 3 for x, I can solve for y. Okay, so let me give you an example. So let's say if I had y equals 2x minus 1, x minus 5. Okay? I found that the axis of symmetry is at 3 because my zeros are at 1 and 5. Good? Okay. Zeros are 1 and 5. Axis of symmetry is 3. If I plug in that 3 into my equation, I'm gonna make this negative. If I'm gonna plug in that 3 into my equation, then I can solve for y, which is gonna give me the optimal value. Okay, so let's try that. If I plug in 3 here, so y equals negative 2, 3 minus 1, 3 minus 5. So that gives me negative 2 times negative 2, which is going to be 8. Right? So that means my optimal value is at 8. So my vertex is at 3, 8.
Oh, so to find the vertex, all you have to do is just like solve the
Zeros.
I get it because it says y equals.
Mhm.
Okay.
So find the zeros, find the axis of symmetry, which is in the middle between the two zeros, plug that axis of symmetry into your equation for x to solve for y.
We're squeezing lemons. This is easy peasy.
It is, right? So to find the optimal value, plug the axis of symmetry in for x and solve for y. And that's going to give you your vertex, which is
Find your ultimate value of play, sister.
plug.
Plug.
So this is if I have the factored form. What if I have the standard form, which is y equals ax squared plus bx plus c? How can I find the vertex from standard form? Do I know what h and k in the standard
You
form?
have to factor it first,
I have to factor it and then
and then do the same thing on the top.
exactly. Right? We haven't learned a way to go from standard form to vertex form. Right? We did not learn that in this course. Okay? So, in order for us to be able to find the vertex from the standard form, I have to factor. I know how to factor. Right? So, the first step is to factor. Then follow the steps above. Easy?
Miss,
Yes.
I am really confused. They said to follow the step above, but above we know h and k.
Where do you know h and k?
It's like negative 1 and then, no wait, never mind.
You know the zeros.
Yeah, we know.
Yeah? And And then if you put it in factored form, what would you know? What would you be able to find in factored form? Huh? What can you find from factored form?
The zeros.
The zeros, right? So that's why I put it in the factored form. Because then I can find the zeros.
So
Okay? Now the third form that we know is called the vertex form. How can I find the vertex from the vertex form? H and K. The easiest thing you can do is find the vertex from the vertex form, which is the vertex is H and K. There is not much that you need to do. Okay? So if it's already in the vertex form, you just state your vertex. So here are some examples that we're going to look at. First example we're going to look at is in the factored form. And it's asking you to find your zeros or your x-intercepts. So what are my zeros or x-intercepts?
20.
So I just write 2 and 8. That's what I would write?
x equal to 2 and x equal to 8.
Thank you. So my 2 zeros are 2 and 8. Does anyone know, doesn't know how to find the zeros? It's right there, right? You set each bracket, remember this, you set each bracket equal to 0, right? And solve for x. So bringing the negative 2 over, that's x equals 2, right? Same with this, set it equal to 0, bring the negative 8 over to isolate for x, so x equals 8. This is how you find your zeros. We're okay with this, right? All right. Then it's asking you to find your axis of symmetry. How do you find your axis of symmetry?
8 plus 2, 10 divided by 2.
So you add your 2 zeros and divide by 2, right? So the axis of symmetry, again, it's an x value, right? Axis of symmetry passed through the x. So you add your 2 zeros, so in this case 2 plus 8, and then you divide by 2. So that's 10 over 2, which is 5. So that I mean that I know that the axis of symmetry is at x equals to 5. Are we okay with this? How do I find the optimal value? Axis of symmetry. How do I find the optimal value?
The optimal value
Plus
is
5 for x and so.
Remember, if I go back here, to find the optimal value, I plug the value of the axis of symmetry in for x and solve for y. So I have to plug in 5 in for x. I'm just going to write it down here because it won't fit. Okay? So I'm going to write y equals negative 3, 5 minus 2, 5 minus 8. So what I did is I plugged in the value of the axis of symmetry in for x. And solve for y. So that's going to be negative 3 times negative 3, which is 27.
Isn't it negative?
Negative times negative gives you 12. Yeah?
it's 24.
So the optimal value is y equals 27. Are we okay with this? Okay? So what's your vertex then?
5 and 27.
5 and 27. And how do I write that? Bracket. That indicates a point, right? It comes in bracket. Good. So if I want to write it in vertex form, because it's asking me for the vertex and the vertex form, if I want to write it in vertex form, how would I write it? And why is it negative 3? So why is it y equal negative 3x minus 5 squared plus 27? Why is it negative 3 here at the beginning?
It opens down.
Yes, but where did you get that negative 3 from?
That's the value of A.
That's the value of A. The value of A is going to be the same with all 3 forms. Okay? You know how we have the 3 forms? We have the vertex form, you have the standard form, and you have the factored form. That A value is the same for all 3. That's the same for all 3 formats. Okay? So if you know what it is in the factored form, it's going to be the same in the vertex form. It's going to be the same in your standard form. Okay? So that's why I have a match here.
In the vertex form, H is equal to the vortex, is equal to the axis of symmetry?
Of course. Remember, if you look at your vertex is HK, yeah? So H is gonna go here, which is your axis of symmetry, and your K is outside.
Sorry.
It's okay. Are we okay with this so far? Any questions? All right, then it asks me to convert to standard form. So you can either pick to go back to your factored form to convert to your standard form, or you can go from the vertex form and convert. It doesn't matter which one you pick. I always like to go back to the original question because just in case I made a mistake here, so my mistake doesn't keep carrying on. Okay?
Okay, yes, done.
So, how would I convert
I don't care about the ones.
factored to standard?
Expand.
Expand. What other name do we call it?
Foil.
Foil method, that's right. Okay, so let's do that. So, sorry guys, it's not fitting properly. Okay, so convert to standard form, so I have y equals negative 3x minus 2x minus 8. So first thing I want to do is I want to FOIL, leave the negative 3 outside, multiply. First is x squared, outer is negative 8x, inner is negative 2x, and then my last is plus 16. Any questions about this?
Actually, then you should just go negative 3.
Sorry?
Just do x minus 5 and then like that way. So x minus 2.
So you want to do this to take the vertex form and expand?
Can we do it?
Yes, you can. Okay? Then I collect like term inside the bracket.
Yeah. Yeah.
And then distribute that negative 3 in.
Minus 48.
It's in standard form, yeah? Good.
That's okay, I just want the zeros. Jordan Lyons and variance.
What can I find from the standard form?
Y-intercept.
A y-intercept. And that's why it's asking me for the y-intercept, right? What would be my y-intercept?
Negative 48.
Negative 40. Remember that this represents your y-intercept. So So I would write it as y equal negative 48, and that would be my answer for the y.
Okay, leave her for
The last is forget about.
About what?
The last number is the y.
now. She might.
So we're gonna do we're gonna do this. Are you guys done copying this? Okay.
There's our 5.
Y equals a x minus r x minus s. What do you call this? Factored. What can I find from the factor? Okay.
Leave him for now. Take it.
What do we call this form?
Vertex.
What can I find from the vertex form? And it's called, and what is it?
It's if they're not.
HK.
I just want to clean up the numbers.
And what do we call this form?
Can you send that one to your?
What can I find from the standard form? Which is? Okay, so basically that sums up all the 3 forms that we talked about. Okay, now yes, with extra stuff, we can go from the factor to the vertex. Sorry, from factor to standard. We can go from standard to factor, right? We can go from vertex to standard. So we learned all of this.